Okay, everybody, we're going to start the next talks real quick. You guys can continue doing your work. It's not an obligation to watch, but here we are. So my name is Ben Sherry. I'm with Biggest Fan Productions, and a few months ago, so I have a R&D, we call it the DNR team now, that's focused on crypto development, and we were primarily on Ethereum. But we have an application that we want to build, and we need fungible and non-fungible tokens, and it got to be really fast and really cheap. And so Corentin talked us into Bitcoin Cash and convinced us that was a credible option. So that's what we've been doing. And not unlike the Ethereum community, the tooling for these crypto projects is really, really, really awful. It's really bad. It's hard to get into it. So we have been working on, so go ahead, go to the next slide. We've been working on getting the infrastructure going because we want to have a full local node that is exactly what you would experience on the mainnet or testnet, but on your local computer. So we can reset the system and go back from a known good state, automated testing, all the good software development engineering practices that you would have as a regular software development company, which is completely absent in the entire crypto space. It's not just Bitcoin that has this problem. Everybody does. So we've been finding all these projects. We found like 3 different tech stacks and figuring out which one we can make work locally. And I think we got 2 out of the 3 going this week. So now, as a little side project, and everything that we're doing is open source for this, and we're hoping that it will help other people be easier to get into crypto development. You went ahead too fast. That's your slide. So we now have it where you can type 2 script commands and have a full development node for Bitcoin Cash with SLP support. And SLP is the little smart token mechanism that supports fungible and non-fungible tokens on top of the Bitcoin Cash network. And so now we have repeatable deployment states, and we're not locked in by any third party. As it turns out, one of the major tech stacks has removed their open source middle system, and they now have it as a proprietary service online, which we did not discover until late. So we've made an open source replacement of that you can use and plug into your local node, so you still have the full experience. So I got 3 of my staff here have been working with it, and I'm going to leave it over to them to actually demo the thing. So this is Nick.
Yes.
Or no, it's Slava's first.
All right. So let's go ahead and dive a little more into the details of what Ben just told about. So this is one of the examples of how an average developer would, of what an average developer usually works on. So here you have basically the full picture of the whole tech stack of. So basically, an average developer would do their development on the SDK level, building tokens, sending money within Bitcash or Bitbox libraries, just like Corentin demoed last month. Exactly. But not a lot of the developers actually dive into details and try to look at what's under it. So basically, every level actually relies on something below it, and you have multiple levels starting from the highest abstractions levels, the actual Bitcoin Cash SDKs, all the way down to the node itself. But it might seem kind of simple, but it's not that straightforward. Why don't you just pull everything locally and just do your local development there? So let's start and look into the highest levels. So first of all, these levels, the SDKs actually have the hard-coded API endpoints, meaning that the endpoints where they get all the data from are essentially hard-coded, and all the information they get is either from testnet or mainnet and nothing else, meaning that there's no way for you to do any local development on that level. And if you dive deeper, right, and you try to check the rest.bitcoin.com service, you will see that the REST.Bitcoin.com service cannot even handle regtest addresses properly, translate them from the legacy addresses, those inherited from times ago, and the current modern types of addresses. So, moreover, REST.Bitcoin.com actually relies on some proprietary service called Ninsight, and it's closed sourced, so you have no access to it and you have no idea what it's doing. You just might guess what kind of information it returns and how it does that. But you're 100% sure that it's based on the node. So, and basically we got all this patched, and can I go next? So, we created something called OpenSite, which is an analogy to Insight, their proprietary closed source service, but it's been made by us, and we of course made it open source, and it does all the bare minimum things that are needed for the upper levels to fully function. So if you go and it may not be that clear, but what it says is that it basically So we of course we removed all the hard-coded things, and we rely to your local environment, and and REST.Bitcoin.com service actually relies on our OpenSite and something called Electros Cache. Electros Cache is some indexing service built according to Electrum protocol. That's some implementation details, but yeah, those are quite important. Can I go next? And so of course, and we managed to get the highest levels working, of course, and it can fully connect to your local environment, and it can handle your regtest addresses, and these are the things that make you able to do the actual development on any local environment. So, and this is the whole stack, an example of one stack that we have working. Spoiler alert, it's not the only one. And I believe that Nick is gonna demo how this all works. So, yeah.
All right, so demo time. So specifically, we have all the lower components working, but there's not really much to see in the way of that. But what you can, visually see is I'll be using this Bitcache SDK and using some of the functionality of that. And the fact that the Bitcache SDK works against the local node, implies that the rest of these services are working as you might expect. So I don't know if that's big enough. I can zoom in. All right, so over here I have the actual Bitcoin node, and I can check some of the stuff. So we'll get the blockchain info. And here you can see that on my current local network, not the main net or the test net, but the local Bitcoin Cash network that's running on my local machine currently has 240 blocks created. And it's really simple to use this thing. You can just generate 10 more blocks. They're done, and I can get the info, and now you see I have 250, so there's 10 have been generated. Down here we have that OpenSite, which as Slava mentioned is a implementation of Ninsight that the guys behind Bitcoin.com currently have as a proprietary service. We have this OpenSite that handles all the same RESTful calls that Ninsight does for the most part, and allows us to use things. So in Python over here we can import Bitcache, which, if you remember, is this top level API over here. We can, let's say, my name's Nick, by the way. Hi, everyone. We can take me, and we can give me a new private key for the regtest network. and we can check what my address is for this private key, and something previously that Bitcash did not have. So let's make someone else. I'm spelling that right. Previously on Bitcash, when you did a private key, you had two choices. You could either create the private key or you could create the private key for testnet. So now we've added this third option where you're able to do things against your local machine, which was not previously a functionality of these SDKs and other parts of this tooling. So now I've created my account and I can check if I have any money yet, which the answer is no. And what is your name, sir?
Arthur.
Arthur. So we're going to take Arthur. Did I spell that right? Arthur. Okay. Like that or O-R? U-R. Okay. So we're going to go ahead and create a private key for you as well. And now we're going to check your balance real quick. And you also have no money. We're in the same boat. So let's go ahead and check how much money exists on my network, which is about 6,000 Bitcoin Cash. We will send some of that to my address here. A specific amount of 650. That sounds good. And now after you do any sort of transaction on the network, you'll also need to generate at least one, but you can generate more if you want, blocks, because otherwise the transactions won't be confirmed yet. So now that I've generated a few blocks, that money being sent to me will have been confirmed, and I can come back here to Python, do get balance again, and now you see I'm not poor anymore. To send money within this Bitcash Python framework, it's a lot simpler in Bitcash than it is to try and do things manually through the terminal in the node itself. Like if you're trying to construct things there, it's quite complicated, but this Python library makes it nice and simple. I can just choose an output, put some information in here. We'll do Arthur's address. We'll send him 500 and some random number here in the denomination of Satoshi. And now I'm going to do nick.send output, and that returns me the transaction ID of where that transaction, where I sent money to you. Again, to make sure that gets confirmed, I need to generate some more blocks. And now if I check you, you are not poor anymore. You have a few pennies worth of Satoshi now. But it's actually a local node, so it's really, not worth anything. But yeah, so some of the convenience of this is the fact that on the testnet, you would have to go and actually, I think, subscribe to like what they call a faucet and have money sent to you, and you have to wait for that to happen. Or if you're developing directly against the mainnet, you would actually need to take your fiat like US dollar or Thai baht, convert that to Bitcoin Cash, and then you can do transactions. And some of the downsides are that you don't have this control. I can sit here and generate more and more as to my heart's content, and yeah, everything just works great on the local node. So where was I at on here? Okay, so that concludes my demo, and
All right, hello everyone. So what we're doing here is like a crypto project. The reason why you should care about this stack is because it allows you to develop financial application very, very easily and permissionlessly. If you ever try to build some financial application through payment gateway like Omisego or other payment gateway or to connect to the bank, it's very hard. You need to do KYC. This crypto project is permissionless. That means you can develop financial application you may create a paid out application, so you can pay your employee with Bitcoin Cash, which this is something that you cannot do with this payment gateway. So this is one of our stacks that we built to bring the Bitcoin Cash have an API, but it's on the cloud and it's some of them are proprietary. So we try to bring that on the cloud down to your local host to make it very, very easy to develop and costlessly doing so. You have very high control over the whole stack because it's run on your local machine. This part is the same as the one before. But this time we're gonna use the BCH API, which is a fork of another project for it's an uniform API that allow you to develop this financial application very, very easily, and you will see soon. And this is the SDK that connect to the API to like make it very easy to programmatically program this financial application. So today we're gonna do some demo that involve create a wallet. We'll go through this very quickly. Create a test token. We call them reg test because our local node is a reg test. That means you can like generate a token on demand very easily, unlimited, basically. We're gonna try send some Bitcoin Cash to another wallet. We're gonna check the wallet balance. We're gonna create SLP token, which is a token that it's a color coin. It means you bring Bitcoin Cash and you add some another data on top of it, so you can create utility token like USDT, which is like have like $1 billion valuation right now that are built on top of Bitcoin Cash on the mainnet. You can like create your own token and maybe tie it with Thai baht or tie it with any currency that you want. So there are a lot of financial applications that you can try. So we're gonna send that token to another account as well. We're gonna check the balance from the wallet, and we're gonna do SLP lookup, mean we're gonna check what the data of that wallet, data of that token is. Let me show you again. Okay, this is our stack. As you can see on the left, this is all Dockerized container. We Dockerize the API, which is a uniform API that will talk to the rest of the service that we require in order to develop this financial application. There is a node and the other indexing server down below, but the API will make it uniform. So I have it running locally right now, and I'm gonna first try to generate some block. So this, after I generate the block, the reward, the Bitcoin Cash gonna reward into my account that are in the node. So So I'm gonna generate 100 block. Wait a second. So here is all the block that get generated. I'm gonna try list. This command gonna. Okay. So this command is going to show like how many Bitcoin Cash I have on this account that are in the node. All right. I'm gonna create another separate wallet to transfer from this account to that wallet. Okay. So first, I'm gonna create a wallet. I have made a script. So it's all code, but I will walk through it quickly. So here, this using JavaScript SDK called BCH JS Reg. This one we patched them to make it work with the reg test as well. Basically, this is boilerplate code. As you can see here, it just try to find the right connection. You can connect it up to the cloud or connect it to locally, but this time we connect with the reg test with local node that we run. We're gonna create a wallet. I'm not gonna go too deep into it, and it will basically generate a reg test address, and you can use that wallet to like do other application forward. Okay, I'm gonna run the script, which is here. Right, create wallet. So I create Pat wallet. That's my name. Hello. So this wallet are generate using address. It's a reg test address, which is different from the mainnet address. So if I go to the directory, I'm gonna see this wallet generate. So this is address where I use to send money into this BCH, this cash address. So I'm gonna generate another wallet so I can transfer the money to. I'm gonna call it Slava wallet and create wallet. It's all programmatically done, so you can like hack it out however you like. So now I have two wallets, Slava wallet and Pat wallet. So let's try to check balance of Pat wallet. So here I'm just pointing to my wallet named Pat wallet. Okay, right now I have 0. So I'm gonna send to my wallet the BCH that I mining earlier, that I generate block and get the reward. So this command is the command on the node, which just tell the node and the wallet inside the node where to transfer the money to. I'm going to transfer this amount. Oh, I have to generate more block. I don't have enough money. Generate 1,000. You normally cannot have these capabilities on like mainnet or testnet. You cannot like generate block on the fly and get the token. All right. Okay, I'm gonna send it to my wallet address. Okay, let me check my wallet address again.
You can't have the BCH reg prefix, I think.
Come again?
You have to take the prefix off it.
No.
Oh,
Okay, I may have already sent it. Let's try generate block and check the balance. The reason that it takes time because it do like running some computational hash. Hello. Okay, the block is generate, and let's check balance. Come again? Okay.
the BCH reg part on the beginning?
Oh, okay. I think I sent more than I have. Okay. Okay, now it's worked. So here, this is showing the transaction ID that I just create. So after I send the money, I have to like generate the blocks to get the transaction inside the node. Sorry.
1 million blocks.
It's local node, you can do anything. Okay. Okay, now I have like a lot of money. So what I'm gonna do next is to check another balance of Slava. That wallet that I check is my wallet, Pat wallet. So I'm gonna check Slava wallet to show you that I'm not cheating. Okay, Slava wallet have 0 Bitcoin Cash. So I'm gonna send him some money. So I'm gonna send BCH from my wallet to Slava wallet. Oh, sorry. And that's it. I'm gonna have to mine 10 blocks. Okay, so now transaction is in the node. So let me check Slava balance again. Okay, now I send Slava some 10,000 Satoshi. Yeah, so that's it. That's all done programmatically. You can send money to people that easily if you like doing with the real mainnet. So you can like send 100 to all your employee to create your own like Uber payout, something like that, very easily, permissionlessly. Yeah, so that is the cool part of it. And the other part I'm going to show you is I'm going to create an SLP wallet, SLP token that will allow you to create your own token and get rich. All right, this one I have to like config some data on it, so we can say BCH meetup token. You can name it all you like. You can like initialize the amount that you want to generate. So this is like this is how you initialize your SLP token. So afterward, this data can be like you can like go to the mainnet and check out the data on of your SLP token on the mainnet. So I'm gonna create a token. Okay, that's it. That's how you create like $1 billion evaluation token that easy. The cool part about our project is that it's come with the SLPDB. Okay, thank you. All right, so I need to like generate every time I do some transaction, I have to generate block to get the transaction in the node. So I can query the token that I just create. As you can see here, now it's 2. So, here you are. No, not this one. Okay. BCH meetup token is create. This is token that I create earlier. So, all right. After we create a token, we're gonna try and let's check balance of the person who own this token. So I use my wallet to create a token, so I will check from my wallet if I have a token in it. Here, so I have this amount of SLP token in this particular address. Okay, I'm gonna try send some SLP token to another person. Okay.
Switch to the token you just made, BCH token.
All right, thank you. What is the token? Oh, that's actually correct. Let me see. Send token. All right. Send token. Here we are. We have to specify the right token before we could send, of course. All right, there we are. We have sent a token to another wallet. So I'm gonna go check the other wallet to see the token that I sent to him. Generate the block first. Check balance. Check balance. Okay, so Slava wallet now has 10 SRP token that I just sent it to him. So the last part, we're gonna check Slava wallet again. Wait. Oh, that's already done. Okay. So that's it. That is how easy it is to develop like financial application. It's especially very easy to do it on locally. You can have full control on the node, on how you like configure the node, whether it's a block time or whatever you are in control. So I'm gonna send this to Slava.
All right, so as far as the roadmap and what kind of things we'd like to accomplish in the future, currently a lot of these nodes have this reg test mode built in. However, it is not 100% the same as the main net. Mainly the addresses that it uses and some of the other settings it has are specifically, the addresses have been changed in order to help users avoid accidentally sending, fake testnet coins to the real net or real net coins to the testnet, because you could potentially lose your money or other things like that. And so we would like to kind of sort of bring a localized mainnet to your computer where it's completely identical to what the mainnet is doing, but is running locally, so you can have a complete picture of what you're testing and make sure that there's no bugs or anything weird going on between this reg test and mainnet mode. Additionally, we've patched several of these SDKs and APIs and whatnot. For example, in these two demos you saw, I did the Bitcash SDK. No one has ever used Bitcash to send transactions locally on a computer before, because that's never been a functionality of it. That's something that we've just added in the past week or couple weeks. The same for the JavaScript library that Pat just demoed for you guys. And then finally, there's other applications like the Electron Cash SLP wallet, which again have no built-in support for these local testing modes. So we would like to kind of extend their capabilities so that you can download the Electron Cash SLP wallet, have your local node, and test everything yourself on your machine without having to go and patch all of the code like we've been doing. And you can join our Gitter channel if you have any questions, or if you'd like to set this stuff up yourself and play around with it and get some experience and see kind of how does Bitcoin and Bitcoin Cash, how do they work under the hood. If you want to play around and see how the transactions get sent back and forth, like what kind of stuff's going on, we'll be happy to talk with you in this either tonight or in this Gitter channel, and help you get things set up so that you can play around with this as well. And all of the code that we've patched is available on our GitHub page here as well. So, do you have any closing comments you'd like to make? All right, well, that's our presentation. Thank you.